The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and thank you for joining the webinar, A Backstage Tour of ggplot2 with Hadley Wickham. Presenting today is Hadley Wickham, Professor of Statistics at Rice University. Also joining is David Smith, VP of Marketing and Community here at Revolution Analytics. Today's webinar will run about 60 minutes and we'll take some questions at the end of the presentation. The webinar is being recorded and will be available on our website within 24 hours. If you would like to ask a question during the webinar, please open the questions section of your control panel, type in your question, and click send. We'll try and get through as many questions as we can at the end of the presentation, but as always, please feel free to contact us directly if your question wasn't answered. And without further ado, I'd like to turn over the presentation to our speaker. Hadley, please go ahead.
Great, thanks, Yanni. So, welcome to this backstage tour of ggplot2. So, what I wanted to do is sort of give a little bit of give you a little bit of an idea, like kind of what I was thinking when I started creating ggplot2, and if you're not using it already, why you might want to. So, what are some of the compelling features of ggplot2? Next, I want to give you a bit of a sneak peek at the upcoming features in the next release of ggplot2, show you some of the cool new things that are coming along and some of the frustrating old bugs that have been fixed. Then I want to take a bit of a step back and talk generally about best practices for package development in R. So this is something I'm really trying to do better as a package author, and I think it's useful for everyone to know a little bit about these. So when it comes time to pick an R package, you've got some idea how to evaluate which package is the best fit for your needs and seems to have good high quality programming practices. And then, as Yoni said, we'll finish off with some time for some questions. So before we begin, I'd like to find out a little bit about what you're using already.
Just a moment, sorry about that. Let me get the poll started.
Just while we're doing that, Hadley, this is Dave Smith. Just wondering, what kind of graphic systems do you see people mainly using for doing the kinds of visualizations you're interested in today?
So I mean, R, of course, with base graphics and R lattice graphics and R ggplot2. Outside of R, I mean, I really see this as the JavaScript visualization frameworks taking off. I can certainly talk more about them at length, but I mean, I really think R's in a real sweet spot for data analysis at the moment, because it has the three sets of tools that I think are most important for data analysis. Visualization is what I'm talking about today, but also data manipulation and modeling.
Okay. As the results are coming in, it looks like it's about evenly balanced on the R side between ggplot2 and base graphics. Just in sort of one sentence or so, why would you think that people should transition from base graphics to ggplot2?
So that's kind of what I'll be talking about in a couple of minutes. But in one sentence, I guess, base graphics are good for drawing pictures. ggplot2 graphics are good for understanding your data.
Great. Looking forward to hearing the story around that context. Thanks.
Great. Are we done with the poll?
Oh, yep. Go ahead, Hadley.
Okay. So what I wanted to talk a little bit about is kind of why should you think about ggplot2, and in particular what I was thinking, what were the sort of the unmet needs that I discovered in R graphics. So around 2004, I'd sort of started to move away from base graphics in R to use lattice graphics. And this is an actual line chart that I created for a client in 2004 that kind of illustrates some of the things that frustrated me about lattice graphics. So you can see some of the things that are nice about lattice graphics. So we get this automatic legend, and it's very easy to color the lines according to these groups. But if you look at this legend, you can see the groups. We've got three groups here, 2H, 2M, and 12H. And one of the things I really wanted to do was make the color of the lines map to this color, and then the line type mapped to this letter. So it turns out that that's really hard to do in lattice. And this is sort of one of the things that started me thinking about, well, what is it that we really want in a graphic system? About the same time, I'd been reading Lee Wilkinson's The Grammar of Graphics, which is a fantastic book which outlines a theory that shows us how a very large variety of statistical graphics can be created. So it does this by thinking about what are the building blocks that underlie many, many graphics, and how can we combine them in independent ways to create new graphics. So these two things that Lattice, I felt, sort of didn't have the strong underpinning, the strong theoretical underpinning, and reading about the grammar of graphics, which did provide this theory, really led me towards ggplot2. So you may kind of wonder if you're just using graphics casually to try and understand your data. Well, why does it matter whether or not there's a firm theory underlying it? And from my perspective, it's actually that theory that's really, really important, because it moves the visualization system from being a collection of special cases to being something where you can learn its underlying theory, you can learn about the building blocks, and you can combine them together in many, many different flexible ways to create new graphics that are specifically tailored to your problem at hand. So a good theory helps us to understand all the different types of statistical graphics, even if they previously appeared unrelated, and it also helps us to understand or to give us some tools for dealing with new situations if we want to create new types of graphics that work really well for our data, but no one has ever created before. So there's a few basic principles behind the theory behind ggplot2 that I want to talk a little bit about. And then I'll show you some examples of some cool ggplot2 graphics from around the web that illustrate these principles. So the first principle is that when you do a plot of data, it's going to be made up of multiple layers. So you might have points, you might have some reference lines, you might have a map in the background, and so on. And each layer, it's composed of a data set. Of course, that's kind of the most important thing, right? If you don't have any data, you've got nothing to plot. And then a set of mappings. So a really important idea underlying ggplot2 is that a visualization is basically when we map the variables in our data to things that we can perceive, or aesthetics. So these are things like position, shape, size, and color. Then to display those aesthetics, we need to use some kind of geometric object like a point or a line or a polygon, and often we also need some kind of statistical transformation. So for example, when we're drawing a histogram, we're not displaying the raw data, we're bitting the data up and then displaying the counts. As well as layers, we also have scales. So the scales are the things that control the details of the mapping. So exactly how are our variables mapped, or our numbers, for example, mapped to the colors. So there's many possible ways you can do this. Some are good for some problems, some are good for other problems. And by making this independent, these scale components are independent of the layers, it makes it much easier to control the plot and create the graphic that we want. So another really important principle of ggplot2 is all the components are independent and reusable, so you can reuse scales across multiple plots. It's fairly easy to write functions that create new graphics and so on. So ggplot2 really strives to be a well-behaved member of the R ecosystem. So with that very rough outline of the theory of ggplot2 in place, I want to show you a few examples of some neat graphics, ggplot2 graphics. So I haven't made any of these. I've just found these in my voyages through the web, and I think they're really, really neat illustrations of what ggplot can do. So this first one, it's a map of London showing the popularity of various bicycle routes. So we can see we've got a few layers here in the background. You can see we've got a layer made up of polygons that show the outlines of all the buildings in London. We've got another layer on top of that, which shows the water body, the Thames, and some of the lakes and rivers. And then on top of that, we've got a whole lot of short line segments displaying all of the different cycle paths. And what we've done here with these paths is that we've made the thickness and the color of those paths proportional to the number of bikes that travel along that route. So we've got 3 layers. We're using a map, so basically in all of these layers we're mapping the X position of the objects to longitude and the Y position to the latitude. And you can sort of imagine building up this plot layer by layer, starting with just the building outlines, adding on top of water, and then adding on top of bicycle routes on top of that. So this plot's by James Cheshire. I've added links to all of these original ones if you want to find out more. Most of these have the original code available, so you can see exactly how these plots were created, and there's no wizard hiding behind the curtain. So here's another map plot. This one was created by my sister, actually. So this one is a little bit different. So this one is looking at the ocean, and we've got a layer in the background, which is this tile plot, so you can see the colors. So again, our position is mapped to latitude and longitude. Here, the color of each of these little squares is mapped to the speed of movement, of the water movement at that locations. So on top of that layer of giving us the speeds, we've got a layer of these little arrows which show us the direction in which the water is moving. On top of that, we have a layer that shows us the borders with land and so this data is from whale sharks, and I think these lines, another layer at top, show the typical ranges of where the whale sharks like to swim around. So again, multiple layers. It really helps when you're building up a sophisticated graphic. We can start simple with a single layer, build it up, getting progressively richer and more complex as we go. And again, we're always thinking about how do we map the variables into our data to things that we can perceive. Another completely different display here by David Sparks for displaying model coefficients. So here we've got 9 different models. Each different model is displayed in a different panel or a different facet in ggplot2 terminology. We're showing the coefficients from 1, 2, 3, 4, 5, 6 components of the model. What are the layers we've got here? Well, we have a horizontal line a vertical line in red showing us the 0 line. We've got a layer of dots, of points. That point tells us the estimate of that coefficient for that model. And then on top of that, we've got this band, which is actually made up of a whole lot of line segments, which conveys the uncertainty about that band. So again, completely different graphic, but the same principles apply. We build it up layer by layer, thinking about how we map things in our data to things that we can see. And one last plot, this by Claudia Balates, who entered the ggplot2 case study competition. This is showing some data from spectroscopic grading of gliomas. But you can see again, we've got multiple layers in the background. We've got these hexagons. That's another type of geometric element, a hexagon. Hexagon, like triangles and squares, they're one of the few objects you can actually tile the plane with. On top of that, we've got some lines or polygons, and then we've got some points showing plasticity traits. So we can make up pretty much any type of graphic we can imagine by layering together simple layers, mapping data, variables in our data, things we can see. So what I'd like to talk about a little bit next is, if this has intrigued you enough to learn a little bit more about ggplot2, I'd like to point you to a few resources that might help you learn that. But before I do that, I'd be really useful to find out, so what things do you currently use when you're trying to improve your R skills? So over to you, Yonu.
Great, thank you, Hadley. We have a few requests for you to speak up just a tad bit. That would be great. Okay. And also, there's some issues with not seeing your slides. For those on the call who are not able to see them, please close down and rejoin the webinar. Okay, I'm going to go ahead and close down the poll and share the results.
So Hadley, this is Dave. It looks like a lot of people are using books and the blogs to get information about R skills. But what would your recommendation be for the best place to ask questions and get information about R?
So one of the things that I think is really useful is subscribing to R Help. So certainly you don't want to read every single email that goes to R Help. You'll quickly go insane if you try to do that. But it's a great way to just sort of dabble, skim the subject lines, read about things that seem interesting to you. That's a great way of picking up or improving your R vocabulary, improving and learning new tips and tricks. In terms of asking questions, R Help can be a little bit unfriendly. You definitely need to have a thick skin if you're going to ask questions there. I really like Stack Overflow. There's a great community there around ggplot2 and around R in general, and that can be a great way of getting help as well. How's the volume now? Volume.
Sounds great, Hadley. Thank you.
Okay.
Thanks, Had.
Okay, so in terms of learning ggplot2, some good resources, the ggplot2 mailing list, There's about 2,000 subscribers now. Unlike our help, it's a really friendly environment. No one's going to yell at you if you ask a stupid question. Again, it's a great place if you want to ask questions. It's also great, I think, just to follow mailing lists. It's a way of kind of like, it's sort of like a word of the day type thing, right? You can just dabble in it, read it every now and then, learn some new tips and tricks. It's always easy to find out about techniques before you need to use them, because once you know the name, it's typically easy to Google for them. If you don't know the name, it's much harder. Stack Overflow, as I mentioned to David, I think is another great resource. So it's a community question and answer site. If you're not familiar with it already, I really recommend checking it out. People can vote on questions and answers. So typically, if you ask a question, multiple people will give you the answer, and then you can choose the best one. So the idea is to try and really foster a community that provides good answers to questions. If you're moving from Lattice, the Learn R blog is a really great resource, which basically goes through each chapter in the Lattice book and shows how to convert your Lattice graphics to ggplot2 graphics. Another book that's in progress by Winston Chang, who you'll hear more about a little bit later on, is the R Graphical Cookbook. So this is a really nice summary of sort of how to create many common graphics in R. It's great. You can just skim through it, look at the pictures, or you can actually read in a little bit more detail, and it answers many common queries about how to create different types of ggplot2 graphics. So this book, Winston's working on at the moment. It's going to be an O'Reilly book. I think it's going to be something like the R Graphics Cookbook. And then last but not least, you can always buy the ggplot2 book. So while I strive to make as much of the documentation freely available online as possible, really it does help to kind of read the book, which goes into much more detail about the underlying theory and how all the pieces fit together. So it's available on Amazon. The other option, if you're at a university, you can often get it for free or cheap through springerlink.com. And I'll put all those URLs up again at the end so you can copy them down if you're interested in trying any of them out. Okay, so what I wanted to talk about next was some of the new features in the next version of ggplot2. But before I do that, I'd like to hear a little bit about why do you use visualization, and then I'll try and tailor what I'm pointing out to the things that you want to hear about.
Great, thank you, Hadley. We'll give everyone a moment to complete their selection.
While we're doing that, Hadley, just a question for you. I mean, have you seen a lot of changes in the way that people are using visualizations for data analysis these days?
I don't think so. I mean, that's sort of a hard question to answer. I mean, I guess, I have my own fairly opinionated way of doing visualizations with ggplot2. And I think, and I sort of surround myself in the ggplot2 community, so it's sort of hard to tell how much is changing. I think, by and large, the people are struggling with the same things they've always struggled with, which is really how do you turn your data into useful knowledge or insight and understanding.
Yeah, it's interesting to see in the poll results. It looks like 2-to-1 more people are using it for reports and presentations as opposed to for data exploration, whereas, I use R mainly for data exploration side of things. So it's interesting with this crowd that we get that ratio.
Yeah, that's really interesting. So one of the things, which I'll get to in a little bit, is, personally I'm interested in ggplot2 for exploratory data analysis. And so I think you can kind of see that there's maybe not quite as much spit and polish on some of the things that are so important for reporting, like really good legends and labels and so on. But fortunately, as the ggplot2 community grows, I'm starting to get contributions from other people that are interested in those things. And for example, I'll be showing some really big improvements to the legend system very shortly.
Yeah, that'll be cool to see. I'll let you continue. Thanks.
Thanks. So what I wanted to show, so first of all, if you want to install ggplot2 in R, you can just use this install.packages function. That's going to get you the CRAN version. If you're interested in getting the development version, I've written another package called DevTools, which is basically tools for making package development easier, and that provides a function called install GitHub. That'll install ggplot2 from my GitHub account. That's the development version of ggplot2. So if you want to try out any of the things you see here, this is the easiest way to get it. And one of the other features in DevTools is this dev mode function. So what that'll do, it basically creates a separate place to put packages that you install. So when you install the development version of ggplot2, it's not going to break your existing code, which relies on the CRAN version of ggplot2. I'll also be showing you a few little online demos. I'll type in some R code and run it for you. To distinguish between the development mode, I'll use this kind of futuristic looking black and green, and for the CRAN version, I'll use this black and white version. We'll get to those, some little online real-time examples in a few minutes. Okay, so the first thing I want to talk about were a few new geoms. And again, I haven't written these geoms. These have been contributed by Winston Chang. And these two geoms I want to talk about are specifically developed to deal with overplotting. So here I've got a plot that comes from one of the built-in data sets in ggplot2, the MPG data set. On the x-axis, I've got the type of car, two-seater, compact, and so on. And on the y-axis, I've got the highway miles per gallon. So you can see there's a discreteness in this highway variable. It's rounded to the nearest integer. And so one potential peril here is that we can't tell if there's 1 point here or if there's 10 points, which is potentially very, very important if we want to interpret this graphic correctly. And for each plot, I'll show you the code down the bottom, just using very simple ggplot code. Put class on the x-axis, highway miles per gallon on the y-axis, using the MPG data set. So one geom that's been available for a while in ggplot2 is the jitter geom, which basically just adds a little random noise to each plot. So this is kind of, it helps a bit. We can see there's a few more points around here. But the randomness also introduces some problems at the time. So Winston's contributed two new geoms. The first of all is the violin geom. Through access of geom equals violin. And that basically displays a density plot for each of our individual classes, so it makes it a little bit easier to see where the majority of the points lie. So the disadvantage of the density plot is that it's effectively smoothing the data. It can introduce distortions just because of the way that the smoothing occurs. So an alternative is the dot plot. So here the dots are basically stacked so that they don't overlap each other. Unfortunately, I didn't tweak the parameters quite right in order for the different groups not to overlap. But you can see this certainly makes it easier to see where the majority of the points lie. And it's a very, very useful type of graphic when you've got a small number of data points. Another major contribution has come from Koshike Takahashi, who's been working on, among other things, improving the legends. So here I've got a scatter plot of just some random data, and I've colored the points according to some other continuous random value. One thing you'll notice here is that the default gradient color scheme in ggplot2 has changed. It now goes from sort of a bright, intense blue to a darker, less intense blue. It should be a little bit more obvious, which is the high end of the scale now. But one thing that's a little confusing here is that even though this is a continuous color scale, the legend looks discrete. So there's the code I used to create that. So a very simple plot, X and Y, and then mapping color to this color variable. So there are a whole lot of new features. You can sort of arrange your legend in all sorts of ways. You can split it up into multiple rows. You can say whether you want them arranged by row or by column, put them on any side of the plot in any order. Many, many more ways of controlling the way that legends look now. Another thing that Koshike's added is a new color bar legend. So this shows that this really is a continuous color scale and marks off very elegantly exactly how the colors in the graph, or our tick marks, match up to the colors shown in the graphic. Another thing that you can now do that comes up fairly frequently when you're doing plots of large data. You've got a lot of points. It's often useful to make the alpha value, the transparency, something less than 1. The problem is that when you do that and you look at your legend, it's almost impossible to tell what those colors are supposed to be. So now in the guide setting, the guides which refer generically to axes and legends, you can override some of those aesthetic mappings. You can say, I want the alpha to be 1, so they're completely opaque, so we can now more easily see what those colors are. So a lot of improvements to the guides in this version of ggplot2, and generally the documentation is also much better. You can look at the help for guide legend or guide color bar and see all of those many, many options. One of the other things that's been really bugging me for a long time is some of the problems with the layout. So I'm going to quickly illustrate this with some code. So here, this is the CRAN version of ggplot2. I'm going to load up ggplot2, and then I'm going to run this very simple plot. So this uses a fixed coordinate system, so 1 unit of the distance in the x-axis is always the same as 1 unit of distance in the y-axis. If we resize this a little bit, we can see there's some problems with the plot. This guy, this label's floating away off in the distance, and this guy doesn't look very centered. If we run that now in the development version, exactly the same plot. When we resize it, you can see things now look much better. This X looks much more centered, and the Y-axis label always stays with the plot. So this is something that's been bothering me for years. It took a surprisingly large amount of work to fix, but as well as fixing this problem, I've really tried to improve some of the underlying infrastructure in ggplot2 to make it easier to add new features in the future. So for example, one of those features that the underlying changes will make easier to implement is adding secondary axes. If, for example, this was in centigrade or Celsius and you wanted to add a secondary axis, which also had it in Fahrenheit. There's also another long-standing bug in ggplot2. If you faceted by a variable with a name, the same name as aesthetic, that would also get used to color the points, even though we haven't asked to color the points for us in the new version. That is fixed, so that doesn't happen. Again, just a little annoying thing that bugged me a lot, probably didn't bug that many other people, but I'm really trying to improve the underpinnings of ggplot2 as well as the visual results. The other thing that I've been working on slowly in ggplot2 is making it a little bit faster. So here I'm going to do a couple of timings, just doing a plot of the diamonds data set. So here I'm going to run it in the CRAN version of ggplot2. And then once that's done, I'll run it in the development version. So here it took a little bit under 8 seconds to create this plot. In the development version, hopefully, fingers crossed, will be a little bit faster. So it's about 6 seconds versus 8 seconds, so not a huge improvement, but you should see a fairly consistent speed improvement across all of your plots in ggplot2. So by and large, I'm kind of most interested in making it as easy as possible for you to express the plots that you're interested in, to get the plot in your brain out into the plot onto the computer. But as ggplot2 becomes more mature, I will spend more time optimizing the performance as well. The other thing I wanted to talk about were a couple of new geoms that are special cases so geom raster, for example, is a special case of geom tile that's much, much faster, and geom map is a special case of geom polygon for the case when you want to do choropleth maps, also much, much faster. So here's a quick illustration of that. Here's another map plot with ggplot2. This is a plot of Houston, so we've got a map of Houston in the background, and on the foreground, this contour plot, we're showing the density of thefts in ggplot2. So this was inspired by the ggmap package by David Kale. So the ggmap function uses geom tile takes about 30 seconds to draw a plot like this. In the new version, you can use this new custom annotation raster function, which is basically designed for this case. We want to put an image in the background here. You want to put an image of a map in the background. Only takes 8 seconds. So for some types of plots, got some really, really big speed improvements. And here's the plot. Here's the code that I used to create that, just so you can see exactly what's going on. I won't talk through that in detail. I do want to point out one new function in ggplot2, this function called bench plot. Let's just run that with this plot. So the idea of bench plot is this is just a way to help me understand where the time's going. So it breaks down the various steps into different pieces, and we can see exactly what's taking the longest amount of time. And here it's taking about, the majority of the drawing time is in the drawing step, which is taken care of by grid graphics, which is largely out of my control, although there are often things I can do to speed the drawing up. Okay, so ggplot2 0.9, that's the development version, is scheduled for release on March 1st. So the other thing I'm trying to do with releases of ggplot2 now is schedule them sometime in advance. So I'm going to try and aim for about at least a month's notice, so that people whose packages depend on ggplot2 have time to update them. And if you're using ggplot2 in your everyday workflow, you have some advanced warning so that things are going to change. So one of the other nice resources, which I don't have a link to yet, but it will be available on the mailing list very shortly. Dennis Murphy has been working on a transition document. It's about a 30-page PDF, describes many of the new features in ggplot2, many of the changes, and shows how to change your existing ggplot2 code so that it works with the new version. The other thing I'd like to talk a little bit about is some work that I've been doing with Revolution Analytics on scaling ggplot2 up to really large data sets. And to target that to you guys, I'd like to hear, so generally, how big is the data that you're dealing with?
Thank you, Hadley. I'll give everyone a moment
Those
to...
answers are coming in. Hadley, question for you.
Mm-hmm.
Sorry, I didn't mean to interrupt you there. I was just going to ask Hadley though, like, what's the biggest data set that you've dealt with in terms of visualization, and what was it, and what were the challenges of visualizing it?
So the sort of one of the data sets that I've been using to kind of motivate this big data work is the ASA Data Expo Challenge on visualizing flights, all flights within the continental US for about 30 years. It's about 120 million observations in total. So it poses a significant challenge. And I think there are really two challenges when dealing with big data or visualizing big data. So first of all, there's just this sort of technical challenge. How do you get it in memory? How do you make sure your functions only take seconds to run instead of hours to run? And then there's a sort of conceptual challenge that, you know, you can't do a data analysis on 120 million observations in the same way that you can with 120 observations.
Yeah.
So so I'm sort of interested research-wise in what changes. How do you create what does a scatter plot look like that works, or the equivalent of a scatter plot that works when you've got 120 million observations, not 1,000 observations?
Yeah, and it sounds like that's going to be a big issue to lots of people too. I'm actually surprised to see that, you know, a good 22%, actually adding it up, 30% of people have data sets bigger than a gigabyte, you know, which is, you know, still pretty large for visualization, and a lot of people, 7% more than 100 gigs, and 5% even more than a terabyte. So there's some huge data sets to visualize.
Yeah, that's definitely a challenge, and something that it's really fun to work on. So the basic challenge is, how can you make a plot of 100 million observations? And the secondary challenge is that I think to be able to do interactive data analysis, you really want that plot to happen in less than a minute. So I've kind of picked a minute as my sort of benchmark. My feeling is if it takes more than a minute, you stop waiting for it and you go and check your email, you get a cup of coffee or something, and then you forget what you're doing. So the idea is, how can we do this in a minute or less? And I've been working with Revolutions, in particular the RevoScale R product, and with some undergraduates over the summer, thinking about both what should graphics look like and how can we compute them efficiently. So here's a scatter plot from another built-in data set in ggplot2, the diamonds data set. On the x-axis, we've got the size of the diamond, the y-axis, the price, and then we've colored it by the color of the diamond, where D is the best quality, J is the worst quality. So looking at this, it's just a huge mess of overplotting. Maybe you can see that there are more J's kind of on this side, and maybe there's some suggestion there are more D's and E's on this side, but it's pretty hard to see. So the basic idea, I think, is when we have very large data sets, we want to switch from thinking about plots of data to thinking of plots of distributions. So what we've done here is basically binned the data up into little rectangles, and inside each rectangle we're displaying a little bar chart that shows the distribution of color. So you can maybe see on the right-hand side a bit more easily, we get more of these low-quality colors. On the right-hand side, we get more of the high-quality colors. So a similar thing arises when we've got plots, 3D plots. We've got 3 continuous variables. In the previous plot, we had 2 continuous variables and 1 categorical. Except here, we might want to start thinking about, as well as binning the plots, binning the points up into little rectangles, we might also want to add in a little bit of smoothing to get density plots. So the same idea here, and each little rectangle is summarizing the distribution of diamonds at that location. So here we're looking at depth and table, 2 physical measurements, and then with on the color, or the third dimension, is another measurement, Z. And maybe you can see that it looks like there's actually quite big differences, well, quite big changes in the distribution as we go from one side of the plot to the other. To give you a little bit of feeling for how long this is going to take, this is another data set that I've been working with, movie ratings from the IMDb. So there's about 100,000 observations in this plot. It took about a 20th of a second to bin them all up, about 2/10 of a second to convert them into a data structure that ggplot2 could use, and then another 6 seconds to plot. Scaling that up with a bigger data set I've been working with 1.2 million observations, it takes about 10 seconds to do the binning, and will take about the same amount of time to do the other 2 pieces. So I'm really excited about this. This is still very preliminary work. Still working with the developers at Revolutions to make sure that we have exactly the computations we need for doing these types of graphics as effectively as possible. But I think this is, and so the other thing that's really neat about this is that it scales linearly in the number of data points, but also the speed, the performance scales linearly in the number of servers or number of cores you have allocated to the problem. So if instead of having 1.2 million observations, you've got 12 million observations or 120 million observations, you just need to buy more servers and you can still keep that interactive visualization time. So you can continue to explore your data interactively. I wanted to conclude with a little bit of a discussion of best practices for package development. And again, before I do that, I mean, how do you guys currently learn about new packages? Or how do you pick new packages when there are multiple options available? Johnny, do you want to start that survey?
Yes. The poll is currently live.
Okay.
And while that poll's running, I'll just give a little shout out to Hadley here because I know he's about to mention it, but the crantastic.org website is a great place to look for recommendations of packages, and you can go there and vote on those packages as well. I'm sure Hadley will be too modest to mention that he was behind the creation of that. So looks like the poll results are just coming in. Looks like it's about evenly split between recommendations and other. So I think that's a good sign that having a good place to find recommendations for packages online is something the community could use. So thanks for putting Crantastic.org together, Hadley.
Interesting. Thanks, David. So I just wanted to talk about kind of 3 sets of package development best practices that I'm trying to do and things that I think you should look for when you're evaluating a package. So package namespaces, package documentation, and unit testing. And then I have one sort of point. I would really strongly encourage anyone who's using R or using R packages, make sure you download the source code of packages and read it. It's a great way of learning how to program better. It's a great tool for allowing you to evaluate whether a package is well written or not. If you look at the source code, if you can't understand it, that's generally not a terribly good sign. So I'm going to want to make one little caveat before I talk about this, and that ggplot2 is definitely not the best always the best example of good programming. It was the second package I've ever wrote. I've now written over 30. So I know a lot more, and while I'm trying to incorporate that knowledge into ggplot2, it is a rather slow process to bring everything up to spec without breaking existing code. So just to show you, if you're not already familiar, if you want to get the source code for a package, every package on CRAN also has a link to the package source. You can download that, see all of the R code and the C code and everything else in the package. Really good idea to read that to help improve your R skills. So one thing I wanted to point out, one big change in ggplot2, and let me just start up my R instances again, just to highlight the difference. So in this one, I'm going to turn it into development mode and load ggplot2. And in this one, I'm just using the CRAN version. So you see this version's pretty chatty, right? It tells me it's loading some other packages, it's got some conflicts and so on. And if I use ggply, trying to use ggply, which is a function from the plier package, it's available to me right away. If I try and do that in the development version, it doesn't work. So one of the important things with namespaces is that basically the idea is that a package should avoid polluting your namespace as much as possible. So the idea is that when you load ggplot2, you should only get access to ggplot2 functions, not to functions from packages that ggplot2 uses. So this is a good idea because it just helps avoid the chances of having the same function or functions with the same name in different packages and causing confusion. So if you want to look at a namespace file, it's called namespace, all in capitals. And I think what you should be looking for is a namespace like this, which explicitly exports functions. These are the functions that are available to users of the package. It's not all of the functions in the package because some functions are just for use within the package. Another thing that I've been trying to do with ggplot2 is to provide more unit tests. So let's just quickly demonstrate that in the development version. We load the test that package and then test ggplot2. So you can see what's happening is each of these little dots is a test. If it's a green dot, the test passed. If it's a red letter, the test failed. And you can see, so I've added a lot of tests to try and make sure that when I fix a bug, it doesn't happen again. So the idea is very easy to run these automated tests. There have been a lot of changes in the back end to make it easier to test ggplot2 objects. So I think this is really important. So this allows me to feel safe that I'm producing high quality code, and that when you use a package, it also provides some guarantee that the author has thought a little bit about what the correct answers should be. And then finally, I want to talk a little bit about the documentation. That's something that's improved quite a lot in the new version of ggplot2, thanks to the efforts of Jake Russ and Dennis Murphy. So by and large, the documentation should be a little bit better. And the examples should all run automatically now. All the arguments should be documented. So this is facet wrap. In the previous version, you can notice the documentation for the arguments was not particularly helpful. In the development version, now much more informative. The other thing that's a good idea to look out for in packages, a sign of good package development, is looking at package level help. So to get access to the package level help, we do package ? and then the name of the package. We can look at that for ggplot2. Unfortunately, that's not something that's particularly well done in ggplot2, but I think that is a sign of a well-developed package. We look at, say, it's another package, or that, but Jerry, the idea of package documentation is to kind of introduce you to the package, show you how the pieces fit together, and point you to more resources. The other thing that's a good idea to look out for are vignettes, so long-form documents that again describe how to use all the functions of the package. ggplot2 doesn't have any at the moment, but we'll be gaining one soon, which is that transition document by Dennis Murphy. Another thing that's good to look for when you're evaluating packages is to look for package citations. So the citation function, very useful both when you're using a package in a scientific publication, you want to know how to cite it, but it's also good because it typically provides the canonical resource that the author thinks that you should learn about the package from. So in this case, it just points you to the ggplot2 book. Okay, so that was a very quick tour of some of the things that I think you should be on the lookout for when you're picking packages, some of the things I'm trying to do better. I think we have a few minutes for questions now, and while those come in, I'll just leave this slide up with more ggplot2 resources so you can get to those links. And I think the slide deck will be available on the website shortly too, so you can get the links directly from that.
Yes, absolutely. Thank you, Hadley, so much. Again, if you would like to ask a question, please open the question section of your control panel, type in your question, and click send. We have quite a few. David, did you want to go ahead and filter through those?
Yeah, Hadley, I've been looking at the questions that they've been coming in. Lots of great ones here. Let me start off with one from Rashi, who asks, is it possible to export the ggplot2 graphics output as like a JPEG or a PNG, WMF, or EMF file? I think they're particularly interested in whether you can do that on a Linux system as well.
So that's not really ggplot2's responsibility. So that just ggplot2 relies on the base graphics capabilities in R. So on a Linux box, I think you can do PNGs and PDFs. I think you can only do WMFs on Windows boxes. Personally, I think there's only really two graphics formats you should be interested in. That's PNG if you want to do a raster version, or in PDF if you want to do a vector version. The downside of PDFs, which are generally the best option unless you have a very large number of products, is that they don't work very well in Microsoft products.
Thanks. And what about SVG support? A couple of questions about that as well.
So I think I haven't looked at this in depth recently. I mean, SVG support in R is improving. There's a neat, let me see if I can find it for you. Paul Morrell has been doing some neat stuff on SVG graphics. I think there's a pretty cool little demo available on his website, if I can find it. And so, for example, here's a ggplot2 graphic. It's rendered as SVG, and it has some animation and interactivity added on top of it. So if I make that a little bit bigger, you can see that I can actually hover around on individual points and skip the values. So I'm not sure how this works behind the scenes, but I think this is a pretty, the fact that you can do this is pretty amazing.
Yeah, that is amazing. I haven't seen these interactive SVGs before. That's really cool. But if anybody does want to just export ggplot2 graphics as a static SVG, as Hadley mentioned, R does support that now. I've got a couple of examples of that on the Revolutions blog, which I can send out to people as well. So moving on, we had several questions about performance. You know, with the current version, actually, before I get into that, Bill mentioned an interesting bit of IBM research that said that for productivity, you know, 7 seconds is kind of the threshold for being able to interact with exploratory graphics. With the current version of ggplot2, can you sort of give some recommendations for people about how to get good performance out of it and talk a little bit about the performance improvements in the future version?
So generally, well, I mean, buy a faster computer is my first recommendation. I mean, generally, some of the data aggregation stuff in ggplot2 is not particularly efficient. So if you can kind of do that aggregation outside of ggplot2 and then plot the results of your models or your summaries, that's generally going to be faster. And I think generally that's what you have to do for very large data sets anyway. You have to summarize the data first and then visualize those summaries. And basically, you know, the performance improvements in this version and future versions are basically based around, as my understanding, of how to write performant code for doing data manipulation in R improves that's going to yield speed ups in ggplot2.
Mm-hmm.
I mean, again, my perspective is that I'm sort of primarily interested in ggplot2 for interactive graphics. And my experience in interactive graphics is the bottleneck isn't the computer, the bottleneck is you. So it's sort of your brain, and thinking about what plot you should do next typically takes more time than drawing the plot yourself. Obviously, if you're in sort of a more of a reporting environment where you're doing the same graph and you want to do it thousands of times, performance becomes much more of a bigger concern. That's something I would like to do in the future. You know, the basic challenges that I face is that I'm paid to do research and visualization, not do software development, and I'm actively exploring ways to fund development in ggplot2 that's done by other people, not me.
Right. Great. And given that there's a new version of ggplot2 coming out, Nicholas asks, are you going to update the book about ggplot2 accordingly?
Not at this point. I mean, maybe in a year or so I'll probably consider doing that. There's still a few more other bigger changes I'd like to make coming up in the next year or so, and then I think ggplot2 will basically be kind of done from the perspective that there won't be any more big changes. And then after that, I'm particularly interested in looking and going back to my original interest in interactive graphics and how can we create graphics that we can kind of publish on the web, interact with, that are both useful for exploration and publication.
Gotcha. Yeah, that'll be a great direction. Here's an interesting question. I hadn't heard this before, but Ben says that you hate graphics that have two different y-axes, like when you plot, say, a time series of wheat prices and rainfall in the same chart. But, you know, they're used all the time. So, I mean, what do you have against those kinds of graphs, and how would you represent data like that?
So there's actually a nice paper on this topic by Petra Eisenberg, I think. Let me see if I can find it for you. I don't know if she has on there. Anyway, it's by, there's a paper by Petra about this exact issue on multiple y-axes. Let's see if I can find it. Yes, a study on dual scale data charts, which basically does a very nice job of laying out the problems with them and then some alternatives. So basically, I totally agree that putting multiple scales on a single chart is, I think, at worst, well, at best it's misleading, and at worst it's kind of downright deliberately confusing. So basically, it's sort of a visual task that we're not very good at, and something we should avoid in general. But this is a nice paper that kind of goes into that in more details, backs it up with some perceptual studies, and provides some alternatives.
Okay. And sort of on a similar note, Senthil asked the questions about, you know, how about 3D charts? What about those?
So again, I'm not totally opposed to 3D charts. I think 3D graphics only work well for a limited set of cases, and that's when the data actually kind of represents something physical. So, you know, the way we perceive, so to me, the essential problem is that you have a 3D model of the plot on the computer, you project it onto a 2D display, that gets read in by two 2D inputs, which are our eyes, and then our brain converts that back into a model of a 3D object. And our brain uses, by and large, a set of heuristics to do that, like things that are further away, appear behind things, are smaller, are hazier, and so on. And it doesn't work very well when we're displaying abstract data. So to me, I mean, the kind of the interesting cases, special cases for graphics are 2D, and then thinking about ND in general. I don't think the special case of 3D is that interesting in general for data analysis of abstract data.
Yeah, interesting. It's kind of like the only time I've personally seen 3D graphics be really, you know, compelling was actually in an experimental environment where there was a big sphere that you stood in the middle of, and it was a 3D environment that was visualized around you. And that I thought was a great use of 3D graphics, but, you know, I haven't seen too many other compelling cases myself. But that's really interesting. Going back to interactive graphics for a minute, it's good to see there's this direction you'll be going research-wise about interactive graphics. But R actually already has some fairly simple interactive graphics, like you can use the identify function to click on points and label them. Is that possible with ggplot2? That's a question from Ian.
In principle, it might possibly be, but it'll be very difficult because you have to kind of stitch together, work out what panel you're clicking on, what's the closest point, stitch things, sort of do all the reverse transforms that ggplot2 does. That's possible in the latest version. So one thing I should just quickly show, if I do a simple graphic and I print it. So in the development version, the result of printing a graphic contains all of the information about the plot that you need to recreate it. So potentially you could use this information to kind of stitch everything back together and still be able to use the identify function.
Okay, but it's kind of something that the user would have to figure out how to do.
Yeah, and then again, I don't think it's worthwhile to try and figure out how to do that for very limited special cases. I'm more interested in figuring out how to do that in general for all sorts of interactive graphics.
Okay. I think we've got time for just two more questions, but they're pretty simple ones. The first question is, why is it called ggplot2? Why the GG and why the 2?
So the GG is short for Grammar of Graphics, and the 2 is because there was a ggplot which had a very different kind of way of constructing plots using function composition rather than adding components together. And at the time, I didn't want to break people's existing ggplot code when they made this new version called ggplot, so I called it ggplot2. So more broadly, that's the version dependency system in R is not as quite as flexible as I'd like it to be, which causes all sorts of problems from time to time.
Yeah. Okay, and the other question we've had from lots of people is, can you make your slides available, and is the data and scripts, are the data and scripts available to play around with the examples that you presented today?
Yep, the slides will be up on the Revolutions website shortly, I assume, and most of them, the code and data is in the slides, so you can copy and paste them and play around with it yourself. Or if you can't, just send an email to the ggplot2 mailing list, and someone should be able to help you out.
That's right, and everybody who's on the call today will receive a follow-up email with all that information. But with that, I'd just like to give a personal thanks to Hadley for a great presentation today. And I'll hand things back to Yanni to wrap us up. Thanks, Yanni.
Great. Thank you, David. And yes, thank you, Hadley, so much for a great presentation. Again, today's presentation was recorded. The replay along with the presentation slides will be available within 24 hours. A notice of their availability will be emailed to you. So thank you, everyone, for joining today, and we hope you will join us on February 22nd for David Smith's webinar, Revolution R Enterprise 100% R and More. Again, thank you, everyone, and hope you have a good day. Bye-bye.
Thanks. Bye.
Thanks, Hadley. Thanks, everyone. Bye-bye.